In this video, we are going to study definition of Fourier series and different types of Fourier series. So let's begin with the definition. Fourier series is a representation of time domain signal in terms of complex exponential signals. So we know that complex exponential signals are nothing but sine and cosine terms. Therefore, we can simply define Fourier series as we can represent any signal x of t. So this x of t is in time domain. This x of t signal can be represented as combination of sine and cosine terms. So let's say sine of some theta plus cos of theta, and this sine and cosine terms may have certain magnitudes. So let's say a and b. So any signal x of t can be represented in terms of sine and cosine. So these terms may be real terms or imaginary terms. So this representation is called as Fourier series. Here you must remember that this x of t signal is time domain signal, and the representation a sin theta plus b cos theta, it is also a time domain representation. Here the domain is not changed. A time domain signal is represented in time domain only, but the representation is different. So that different representation is nothing but in terms of complex sinusoids. Now let us see the classification of Fourier series or the types of Fourier series. In short, we can represent Fourier series as Fs. The first type of Fourier series is called as trigonometric Fourier series, or it is also called as quadrature Fourier series. Now let us see the representation of this Fourier series. In order to represent this Fourier series, towards left hand side we have x of t signal. This x of t signal is represented as a0 plus summation n equal to 1 to infinity an cos of n omega t plus summation n equal to 1 to infinity bn sine of n omega t. This is representation of trigonometric Fourier series. Here this a0 is called as DC coefficient, an cos n omega t. So this is the even part of signal, and bn sine is called as odd part of signal. So here if you look at this equation carefully, this x of t signal is represented as certain constant value a0, then it is addition of the cosine terms with certain amplitude which is represented by an. So we have cosine terms together added together, plus we have the sine terms with certain coefficient bn added together. So this x of t signal is split up into three parts. First part is called as DC coefficient, and the second two parts are cosine part and sine part. So now let us see how to find out this coefficients a0, an and bn. a0 is given as 1 by t integration over a single period. So this single period can be marked from 0 to t or from minus t by 2 to plus t by 2, but this integration should be over a single period, x of t dt. Similarly, an is equal to 2 by t integration over a single period x of t into cos of n omega t dt, and bn is given as 2 by t integration over a single period 0 to t x of t into sine of n omega t dt. So in this way we need to find out first the DC coefficient A0 using this formula, then An, and then Bn using these formulas. So remember here, this T is called as period of the signal, and this integration for A0, A and Bn is over a single period. Therefore you can take this integrations from 0 to t or minus t by 2 to plus t by 2. So in this way we have the trigonometric Fourier series and its coefficients. The second type of Fourier series is exponential, or it is also called as complex Fourier series. So the representation of this exponential Fourier series is given as x of t signal can be represented as summation n equal to minus infinity to plus infinity Cn into e raised to j n omega t. So here e raised to j n omega t is nothing but combination of sine and cosine in terms of complex values, and Cn is called the coefficient of exponential Fourier series. Here this Cn is given as 1 by t integration over a single period, so we can take it from 0 to t x of t into e raised to minus j n omega t dt. So this is the representation of exponential Fourier series. If we look at the representation of exponential Fourier series and the previous trigonometric Fourier series coefficients, here in case of exponential Fourier series we have coefficient Cn, and in terms of trigonometric Fourier series we have three coefficients A0, An and Bn. So we can represent the relationship between these coefficients as this Cn can be obtained from the coefficients of trigonometric Fourier series as 1 by 2 An plus j into Bn. So this is a relationship between coefficient Cn with the coefficients of trigonometric Fourier series. Lastly, the third type of Fourier series is polar Fourier series. It is represented as x of t equal to d0 plus summation n equal to 1 to infinity dn cos of n omega t plus phi of n, where this d0 is similar to your trigonometric Fourier coefficient A0, and dn is obtained as under root of an square plus bn square, and this phi of n is given as tan inverse of Bn by En. So these are three different types of Fourier series. Starting with the definition, simple Fourier series, it is a representation of any time domain signal in terms of complex exponential. But remember here, one crucial thing is this x of t signal should be periodic. The signals, if it is periodic, then and then we can find out its Fourier series. Then we have the different types of Fourier series. Trigonometric Fourier series, which has three coefficients a0, an, bn. Here remember here that whenever it is trigonometric Fourier series, we have first coefficient as a0. Therefore the limits of summation starts at n equal to 1 and approaches towards infinity. An cos plus summation n equal to 1 to infinity bn sin. Similarly, if we look at the exponential Fourier series, here we do not have any a0 kind of coefficient. Therefore the limits of summation starts at minus infinity and ends at plus infinity cn e raised to plus jn omega t, and this cn value can be obtained as 1 by t integration over a single period x of t into e raised to minus jn omega t. So remember here we have the negative sign in the power of exponential when we are finding cn and not in the basic equation of exponential Fourier series. And then lastly we have polar Fourier series. So it has coefficient d0 plus summation. As we have coefficient 0 separated out, this summation limit starts at n equal to 1 to infinity dn cos of n omega t plus phi of n. So this completes the definition of Fourier series and its types.